Hello student, we'll find out what is the equivalent capacitance when dielectrics are inserted between the two parallel plates of the capacitor. Now when I take two parallel plates of the capacitor and no dielectric is placed between the two plates and only air is there, then I can write down the capacitance is epsilon naught A by D. Now, when the two plates, between the two plates of the parallel plate capacitor, a dielectric constant epsilon r is completely filling the between the two plates, then I can write down the equivalent capacitance is increased. How much it is increased? It is epsilon r times it is increased. I can say epsilon r times C air, right? Now, when the dielectric is not completely filling between the space between the two plates of the capacitor, in that situation, what will happen when a dielectric of thickness T is placed? Both sides air is there. So thickness of air in which electric field is d minus T by 2 is the thickness in which electric field exists in air, and in T thickness electric field is in medium. So in electric field in medium is electric field in air divided by epsilon r, if dielectric constant is epsilon. Now we can find out the equivalent capacitance for partially filled with dielectric as epsilon naught A by D minus T plus T by epsilon r. Now we will observe minus T and this much D0. By D0 the distance, you can feel the parallel plates, the distance has increased, so capacitance has increased. Now if dielectric is placed and we want to maintain the same capacitance as the previous one, then the two plates separation is increased by D0. What is D0? D0 is nothing but T into 1 minus 1 by epsilon r. Now if the distance between the two parallel plates of the capacitor is increased by D0, then we will observe the capacitance remains the same, which was the previous one. Now if I take n dielectrics are placed between the two parallel plates of the capacitor, then we will observe C equals C is equal to epsilon naught A by, I can say, D minus sigma T plus sigma T by epsilon naught. This expression we can write. Now you will observe D minus sigma T is sum of the thickness of all the plates. So D minus T becomes 0. So I can say this value is nothing but epsilon A by T1 by epsilon R1 plus T2 by epsilon R2 and so on up to nth dielectric Tn by epsilon Rn. So this is the value of equivalent capacitance when n dielectrics are placed between the two parallel plates of the capacitor. Now from this, if only two dielectrics, suppose I take the fifth example, suppose I take the two parallel plates, only two dielectrics are there, epsilon R1, epsilon R2, their thicknesses are, let us take, equal. I can say here the equivalent capacitance is equal to epsilon naught A by D. If you use this formula, I can say it is equal to 2 times epsilon R1 epsilon R2 by epsilon R1 plus epsilon R2. Now this is the equivalent, you can say, dielectric constant. By this value the capacitance has increased. Now if you take if three dielectrics are taken, then you will observe it will be 3 epsilon naught A by D, and 3 times I can write 3 times epsilon R1 epsilon R2 epsilon R3, and in denominator epsilon R1 epsilon R2 plus epsilon R2 epsilon R3 plus epsilon R3 epsilon R1. So this way we can find out. Now when the half is flipped, that also we can find out what is equivalent capacitance. So this is how we can find out when we insert a dielectric between the two parallel plates of the capacitor. Thank you. If you like this video, then please subscribe the channel.